there. I will try and illustrate how these answers on the topic on electric circuits can be tackled. Right, so we have an electric circuit here. It says in the circuit below, the connecting wires and the battery have negligible resistance. We have a 12-volt battery here. We have a switch that's open and a 24 ohm resistor, 8 ohm resistor and 2 ohm resistor. A voltmeter connected to the 2 ohm resistor, connected across the 2 ohm resistor. So the first question says, name the quantity, physical quantity measured by the voltmeter. We said that is a potential difference across the resistor. Okay, so it's the potential difference. Okay, right. Then the other question says define the term resistance. Okay, we said resistance is the opposition to the flow of current or flow of charge. Okay, so that's how we can define resistance. 2.3.1 calculate the equivalent resistance of the resistors connected in parallel. So they can use this word, this term equivalent. They can also use the term effective, or they can use the term total. To calculate resistance in connected in parallel, okay, before we do that, we need to identify the resistors connected in parallel. It is this one and this one. Those are the two resistors connected in parallel to each other. Okay, alright, so now let us calculate their equivalent resistance. When you say equivalent resistance, we are saying if we were going to look at them as one resistor, what resistance will they have? Okay, so the formula for calculating equivalent resistance of resistors in parallel is 1 over parallel resistance is equal to 1 over the first one plus 1 over the other one. Okay, so now we can substitute. We have 1 over 24 plus 1 over 8. This will give us okay. The common denominator is 24. Okay, so it's going to be 1 plus 3, and that gives us 4 over 24, which is equal to 1 1/6. So 1 over Rp is equal to 1/6. That means Rp, the parallel resistance, is equal to 6 over 1, which is the same as 6. So it's 6 ohms. Okay, so we are done with 2.3.1. Then it says calculate the total resistance of the circuit. So we are saying these two have an effective resistance of 6 ohms. When we look at it logically, it shows that these two are connected in series to this one. So now we use the formula for calculating resistance in series. Resistance in series is equal to R1 plus R2. So we can take the RS as our R1, that is going to be 6 ohms plus 2 ohms, and the total resistance of the circuit is equal to 8 ohms. So that's how that is done. Then it says when the switch is closed, the voltmeter connected across the 2 ohm resistor measured 6 volts. Determine the potential difference across the parallel combination. Right, remember when we said this 2 ohm resistor is connected in series to the parallel resistors. Okay, the question is asking us to determine potential difference across the parallel resistors. So according to our knowledge, when resistors are connected in series, they are potential difference dividers. So how is the potential difference going to be divided? This potential difference is going to be divided in this manner. We have 6 volts here, which means here that is where we have a lot of resistance that has to be overcome as the battery is pushing charge through. Here we have less resistance, so more work is going to be done to push the charge across the parallel combination. Okay, so in other words, we can now express the proportion of the division of the potential difference in form of a ratio. Okay, so in other words, we are saying the resistance is going to be divided into the ratio in the ratio of 2:6. Right, so to find the potential difference here, we are just going to do 6 over, you add the 2, you get 8, and you now multiply by the potential difference of the source or the battery, which is 24. So that is going to give us, we can divide here 18 to 24. It goes in there. 3 times 3 by 6 is equal to 18. So it's 18 volts. This is the potential difference across the parallel combination. So which means the 2 ohm resistor is going to be having a potential difference of 24 minus 18, which is 6 volts. Okay, all right. So that's a longer way. We have used a longer way, but a shorter way was just going to say, since the 2 ohm resistor is connected in series to the parallel resistors, we are just going to say 24 volts minus the 6 volts, and we will still get the same answer, which is equal to 18 volts. Okay, but the main concept here is resistors connected in series are potential difference dividers. Okay, then the next question says a charge of 18 coulombs flows through the battery in 6 seconds. Use this data supplied in question 4 to calculate the current in the 2 ohm resistor. So the data we've been given can be used to calculate the current. We know that current is the rate of flow of charge. So it is the quantity of charge divided by the time it takes to transfer that charge. Q over delta T. This is equal to, we can substitute 18 coulombs over 6 seconds. Current flowing here, we say 18 divided by 6, we get 3 amps. So that's the current flowing through the resistor there. Use the ratios to determine the current flowing through the 24 ohm resistor. Okay, right. So now we are saying this current, which is 3 amps, is flowing through here, but when it gets there, it gets divided. Remember we said, okay, sorry for that. Remember we said resistors connected in parallel are current dividers. So that 3 amps is going to be divided between the 24 ohm resistor and the 8 ohm resistor. Okay, all right. The other thing is that we already know the potential difference across the resistors connected in parallel. We've already calculated it in 2.4, and we found it to be 18 volts. Right. When resistors are connected in parallel, the potential difference across those resistors is the same. So the potential difference across both resistors is 18 volts. Okay, so now we are going to use the formula current is equal to voltage divided by resistance. Okay, we will start with the 24 ohm resistor. Right, what is the voltage across that resistor? We say the voltage is the same, it's 18 volts. The resistance is 24 ohms. Resistance is 24 ohms. So if we divide 18 divided by 24, we can divide by 6, and we are going to get 3/4. Okay, which is equal to 0.75. amps. Okay, all right. We can use the same formula to calculate the current flowing through the 8 ohm resistor, where we are going also to say 8. The voltage is 18 volts. We divide that by 8, okay, to get the current flowing through the 8 ohm resistor. But because we also know that when current flows through resistors connected in parallel, that current is divided. So we can just say this current coming from the source, from the battery, is 3 amps. Okay, some of it is going to go through the 24 ohm resistor, which we have said is 0.75. Okay, and what remains, which will flow through the 8 ohm resistor, is the difference. So it's just 3.0 minus 0.75. Okay, I think when we do the maths, we must get 2.25 amps. Okay, so if we add these two, we must get 3. So that's how these questions can be answered.